And so we're going to start out our probability unit looking at tree diagrams. Now, if you're wondering which of these two tree diagrams is the most likely one we're going to be looking at, it's this one on the right-hand side. We're going to make it a little more simple than that, and we're going to relate it to probability, but this is the one we're interested in. Now, when we're done here, you should be able to make a tree diagram. You should be able to calculate probabilities from a tree diagram, and you should be able to recognize some of the terms that we'll be using in our probability unit. That is, things like event, sample space, independent event, and outcome. And so really what I want to do is I want to conduct an experiment. What's going to happen when I flip a coin twice? And we're going to be a little bit innocent here because we probably have a good idea what the possible things are that could happen. Now we're also going to make an assumption just to make things easy. Heads and tails are equally likely, and I'll be totally honest, I don't know what the back end of this coin looks like. Okay, so here goes. We all know I could get a head or could come up with a tail. And I don't think we're too surprised by that, but we're running an experiment here, so we'll be fascinated by all of the possible outcomes. So right now, at this stage of the experiment, which isn't complete yet, I have a head and a tail as possible outcomes. Now, next time I flip it, if I got a head the first time, I could get a second head, and so that means I got a head the first time, and then I got a head the second time, and or possibly I may get a tail the second time, and so I've got a head the first time, and I got a tail the second time. Okay, now we're going to work down the other branch of the tree, and it's going to look like this. Now you'll notice that each of these is a possible outcome, and so in each case this is an outcome. Now all of these possible outcomes taken together are referred to as my sample space, and so all of the outcomes make up my sample space. Now each of these is a possible outcome of our experiment. If we look at everything that could happen, that represents our sample space. Now, suppose I wanted to know the probability of getting two heads when I do this experiment. I symbolize it this way. A p representing my probability function, and then the outcome that I'm interested in symbolized here by a head and a head. Now, the probability of getting a head and a head is actually the number of ways that I could get a head and a head divided by the total number of outcomes. And of course, in this case, that is equal to 1, because there's only one way I can get a head and a head in all this sample space, divided by 4, which is the possible number of outcomes. And so knowing that these are all equally likely in this sample space, the probability of getting a head and a head is 1/4. And so my question to you is, what's the probability of getting a head and a tail in any order? In other words, a head and tail, or a tail and a head. If you said the probability was 2 out of 4, or 1/2, you are absolutely right.